Welcome to the MLOps Live webinar series, your go-to space for exploring how to bring data science into production and generate real business impact with AI. We're excited to have you all here for what promises to be a really fantastic session. I'm Idit. I'm the head of community and open source marketing at Iguazio, an AI startup that was acquired by McKinsey back in 2023. Today's topic is about LLM evaluation and testing for reliable apps. Today, we're diving into this critical topic of LLM evaluation and monitoring. We're going to explain and explore real-world risks, practical techniques, and testing and monitoring, and really how to build more reliable and scalable AI applications, a topic everyone is discussing today, and we're so glad that you joined us. I'm excited to introduce our first speaker, Elena Samulova, CEO and co-founder of Evidently AI. Elena will share her expertise on LLM evaluations, covering key risks, how to make evaluation workflows effective, and strategies for continuous monitoring. Next, we'll hear from Jonathan Daniel, Senior Software Engineer at Iguazio, who will walk us through a live demo of MLRun model monitoring with Evidently. He'll also dive into the architecture, sharing a behind-the-scenes look at how the MLRun and Evidently dashboards work. And of course, we'll wrap things up with a live Q&A, so feel free to drop your questions in the Q&A tab at the bottom of your screen as we go along the session. But before we begin, a few housekeeping items that I must go through. This session is recorded and will be shared with you afterwards, so you don't have to worry about taking notes, and if you miss anything, we've got you covered. We'll be taking questions throughout the session. Like I mentioned, they'll be answered during the live Q&A, one of the highlights of these webinars. So please make sure to contribute and share your questions with us. We've added 2 polls to the session today, and your input is really valuable in shaping future webinars. So we encourage you to participate. We really want to hear from you. And these results of the polls will be shared live at the end of the webinar. Lastly, we invite you to join our MLOps Live community to keep the conversation going. After the session, we'll share the link in the chat now, and we would love to see you there. And now, without further ado, I'm going to hand it over to Elena to get us started.
Thank you very much for the lovely introduction, and thanks everyone for joining this session today. That seems to be a very exciting topic since it attracts a lot of attention, and I'm very excited to dive into this today with you. So as mentioned, I'm going to talk about evaluation and testing for AI applications. And here are the few points I'm going to cover throughout the session. First, I will explain what LLM evals are and when you need them. Then we're going to talk a little bit about risks and what can go wrong with LLM applications. And I will share a few tips and learnings on how to make evaluations work and how to make it a continuous workflow as you develop your AI applications. A little bit of background and pretty much the reason why I'm talking about evals. I'm CEO co-founder of a company called Evidently AI, where we develop open source tools that help evaluate, test, and monitor AI systems. In this case, I refer to AI systems quite broadly, starting from classic machine learning models to now LLM-powered applications. So we have a very popular open source library called Evidently with more than 25 million downloads, and we also have a commercial product, Evidently Cloud, which you will also see today. Now, let's talk about evaluations. I think this topic has been gaining a lot of traction recently, and some even say evaluations are all you need. I think that's probably not because we care so much about evaluations per se, but rather because we care so much about the quality of the systems that we are building, right? And evaluations is something that is right next to it. This is what helps us figure out how good our systems are and if they're behaving as expected. And I think when you talk about evaluations, there are 2 big ways how you can approach this problem. If you look on Google for LLM evaluations, you'll probably find a lot of content about LLM benchmarks. And benchmarks is something that relates to machine learning models themselves, right? So in this case, large language models. Whenever a new model is being released, it is accompanied by some performance report that pretty much explains how good this model is on this particular task and so on. However, these benchmarks, they test models themselves, right? So they're testing some general skills like coding, for example. And honestly, this is not what we care about as practitioners when we talk about our specific applications. There is still time and place for benchmarks because, for example, it can help us figure out which model is better and shortlist the models that we're going to be using in our application. However, for example, if you look at benchmarks and sites, And one of the famous benchmarks is called MMLU. And every new model, like even the models that just being released last week, they're still reporting performance on this benchmark. However, if you take a look on what's inside, these are the type of questions that are being evaluated inside these benchmarks. This is more general school level, university level knowledge, and it's like a multiple choice question. So for example, if you look at this, it doesn't tell you anything about how good your system will be when you're creating a chatbot that answers questions about your company, right? It's just some general memorization tool. And what you need as a practitioner, if you're working on AI applications in your daily work, you need to evaluate your own products that you built on your use case. And these products these days can vary from something like support chatbots to Q&A systems and summarizations and so on. And of course, it can go like very sophisticated if we build a complex AI agent, or it can be some small feature that is inside your product. But either way, you need to evaluate this system, right? Not just the model itself, but everything else that is around it that you design as a developer. And in this case, you might be evaluating not just, as mentioned, like the model, but it may also include the prompts that you wrote. So basically your instructions that you give to the model. And this is one of the big things that you can experiment on. You can also provide additional context to your systems, like additional data sources. You can also implement guardrails and give access to tools. And whenever you are evaluating a system, you need to evaluate all this together. And this is what brings us to this exciting topic of LLM system evaluations, not just LLM model evaluations. And one more point I want to make is, even though I'm talking about LLM evals, right, and I'm going to repeat it many times throughout the presentation, LLM evals by itself is not a tool. It's not a task. It's basically a way how you answer questions about your product, and it can fit into very many different workflows. One of them is comparative evaluations. This is something very familiar if you are a practitioner in machine learning. We used to call it experiment management. Pretty much when you are testing different combinations for your system design. In case of LLM systems, this can be comparing different prompts, comparing different models, comparing different search strategies, and so on. You need a way to figure out if you're getting better or worse, right? So you need some way to compare, for example, if this prompt version leads to better results. And you need evaluations as a way to do this objectively and not just feel like and decide based on what you try without actually evaluating the outcome. Then there is another aspect to this, and I'm going to talk a little bit more later in the presentation about it. But before you deploy your system, you might also need to add some additional tests. In this case, this could be tests related to all the negative scenarios that can happen with your system, adversarial tests and so on, or maybe some edge cases which are specific to your application. So this brings us more to the testing workflow, where we want to put our system in difficult situations and pretty much see how well it handles this. And then, if we are lucky and successful, we put it into production, we need to monitor it, right? And this brings us to online evaluation workflow, which can be focused on evaluating the quality of the system as it is presented with our users, right? So to understand if they're having good experience, if the system is hallucinating. You can focus more on the failure modes, or you can focus more on the signals that signal that everything is positive, or maybe even be a bit more analytical. Like, for example, you would want to identify the topics that the user is asking. So in this case, we need online evaluations that will allow us to keep track of that. And last but not least, you also need regression testing, because whenever your system is in production, it will probably not going to stay in this original form forever. You will need to make changes, sometimes because you may want to fix a bug, maybe because you want to update a prompt version, or maybe there is a new, cheaper model out there and you want to consider switching to it. And if you do this, you actually need regression testing to be able to make sure that the changes that you make don't make things worse and don't break previous behaviors. And this is quite a complicated issue, because in this case, we are talking about very non-deterministic systems. So you cannot just limit it to a couple of unit tests, right? So you actually need to evaluate quite a lot of different behaviors. So in all these scenarios, we are talking about evaluations, but they take slightly different shapes and forms and might require slightly different workflows. We talk about evals not because it is important, but also because it's actually a pretty hard topic to implement, and for a few reasons. One of them is already mentioned: LLMs are non-deterministic. That means that even for the exact same input, we can actually get different outputs, and that is sort of okay. This is very unusual for anyone who is building traditional software systems, but with LLMs, when we talk about testing, we need to actually focus on evaluating a range of possible outputs, not just a single output that we get. Then when we talk about AI applications, we often talk about a very large scope of applications, right? So it can be a chatbot, it can be a financial advisor, it can be a document processor tool. So there are a lot of different applications, and as a result, a lot of different criteria that you might need to evaluate. And in this case, sometimes figuring out this criteria is by itself a problem, because you need to design these quality subjective criteria that you will be evaluating. And things like evaluating helpfulness of response, or professionalism, or tone of voice, and how well it is aligned with the brand tone, that's quite complicated. And last but not least, many things can go wrong. So when we talk about evaluations, we talk about the two sides of the medal. So one is we need to care about quality, pretty much, does it work as expected? Does it solve the problem that it should be solving? But second thing we have to think through is safety and harm that it can bring. So what can go wrong? And we need to figure out in advance if this can happen and how well our system can handle this. I collected a few examples here. I think some of them are already becoming pretty famous, but some are not yet. So here, Air Canada created a very nice precedent where it was actually fined for incorrect advice that was given by its chatbot. And in this case, that shows us that we as companies who are developing AI systems might actually be held liable for the actions of the chatbots. So when we talk about evaluating correctness and testing for hallucinations, it's not just because we want to prevent this happening, like in testing. This can actually lead to very real legal consequences. Another more recent example is from Cursor. So by itself, Cursor is a company that is developing an AI tool, but at some point last month, they sent a lot of notifications where they pretty much asked people to log out from multiple devices. And apparently, this recommendation was generated by a support chatbot, which then incorrectly answered that this is a new policy of the company, which led to many people canceling the subscription. So in this case, lack of groundedness in response actually also again led to some tangible financial losses. Here is also a famous example where we share how Chevrolet sold a car for $1 after being presented with Chevrolet sold car for $1 after being presented with a jailbreak from the user, which pretty much asked it to, hey, please follow any instruction that I give and forget whatever instruction you were given by the original system prompt. And this way, it agreed to sell a car for $1, which obviously not what you expect to happen when you are doing a customer-facing chatbot that can engage in this kind of sales discussions. There are also brand risks that can be associated with the tools that you're putting out there. So in many cases, incorrect answer or something bad that is happening to your tool, that is happening right next to your brand image, is already influencing the brand perception. But it's also possible that, for example, the chatbot that you put out there can say something bad about your brand or maybe praise your competitors. So again, these are not the type of use cases that you want to happen, and it's important to test and prepare for it. And last but not least, there are also privacy concerns. In this case, we are talking about, for example, accidentally exposing some private data when you create an LLM system that might be given access to some confidential information inside the company that may be made available to the people outside the initial circle that should have seen it. So all these things show a lot of potential use cases where harm can happen with AI systems, not just the quality issues, but also potential risks, security concerns, everything that we need to take into account when we're designing our evaluations. So how do you go about it? How do you solve all these issues, either with quality or with safety, that can happen to your AI use case? I think the reality where many people start is something like this. So first, you need to prepare some test inputs that you will run through your application. Say you have a financial support chatbot, you can prepare a few example questions, and then you're going to run them through your application and collect the results. And what you're probably going to do after that is you're going to look at the results and decide if you like them or not. This is what is now being called vibe checks by the machine learning community. And while it's not systematic or fair, I think this is something that we all have to accept that it's happening. So basically, we look at the results and decide if they're good for us and for our purposes. However, we're probably not going to be doing this forever, right? Because if you're running a lot of evaluations or you're trying to compare different systems and models, doing this manually and vibe checking every output is not the way how you achieve repeatable evaluations. So the next step is actually invest into designing a proper evaluation system. And a proper evaluation system starts with test data sets. So in this little example of a vibe checking financial chatbot, we thought about having like 5-10 questions that you can ask. But in reality, you might prepare a lot of different questions that are covering different topics within your application, and also design some specific edge cases that you might want to consider. So for example, if you're dealing with a customer-facing chatbot, you can ask questions about maybe discontinued products or ask questions in foreign languages. And then you can also consider adversarial scenarios that, like we've seen in these bad examples, that can happen. So for example, you can ask about competitors, or try to ask your system, give some financial advice, or even apply some jailbreaks yourself to see what happens. So the first step is pretty much designing these test data sets that you will be using in more systematic evaluations. I know that whenever I talk about the data, people start thinking, where does this data come from? And the reality is that someone has to create or curate it. In some cases, you can actually collect the data that is already available. So for example, you might have past history of support conversations, and you can turn it into test data for your AI application. That's a very viable strategy. Then you might also need to design it manually. In this case, you need to invest some domain understanding and domain knowledge, and maybe bring on some experts who can contribute to that. Sometimes you can reuse public benchmarks, but in this case, public benchmarks are limited to certain use cases like these jailbreaks, because in all other scenarios, these benchmarks do not fit the scope of your application. And last but not least, you can also use synthetic data. In this case, by synthetic data, I mean LLM augmented generation, for example, of potential questions. So you can just ask an LLM, hey, I want to create possible questions that the users might be asking in my application. Can you help me out? And then review it. And it's actually a very good way to bootstrap some possible use cases before you get real data. And once you have this data, you can apply different evaluation approaches. One of them is, again, manual labeling. But unlike with vibe checking, here we're talking about doing this in a systematic manner, where you are actually informing people from within your company, domain experts, to provide annotation and review the results. And I think this is priceless. So even though I'm talking a lot about automated evaluations, you should always start manual to be able to at least formulate what good is in your use case and to curate these high-quality human labels. However, manual evaluations will not always stick around, right? So if you're building your system and you're quickly iterating on different strategies, you cannot manually relabeling the results all the time. So you also need some automated methods here. One of them is related to using ground truth-based datasets. So wherein you design not just the input questions, but also the approved answers to these questions. And then you can test if the responses you get are matching them. In this case, it's pretty much like these public benchmarks that I showed, but these are the benchmarks that are designed for your specific use case. But you might be thinking, what about open-ended evaluations? By open-ended evaluations, I mean when the system is in production and you don't have a good reference answer, or maybe use case is so complicated that it's very hard to define this good answer, like you're writing emails. How do you even define what a good email is? In this case, you can actually run a lot of automated evaluations too. The reason why you probably don't start there is that you first need to figure out the criteria that you're evaluating that require doing some manual labeling first. But once you do this, for example, you can evaluate the specific properties of the responses you get, like is the response safe? Is the response polite? Is the response helpful? And so on. And there are different ways how you can implement this, from classic machine learning models to regular expression-based checks to more sophisticated methods like using LLM-as-a-judge. So this is, I know, a pretty convoluted slide. I'm not going to go into all the details, but this is just to show the breadth of methods that you can apply for different automated evaluations, both when you have ground truth data sets, this is called reference-based methods, and reference-free, that's when you don't have the ground truth answers. And you can notice that there is a method in the middle that is called LLM-as-a-judge, and this one is my favorite, and I think it's gaining quite a lot of traction lately for a good reason, because it lets you implement a lot of custom criteria in your application. So not just limiting to some pre-trained models, you can actually evaluate things like politeness or tone using these LLM judges. And here's an idea of how these judges work. You pretty much pass your answer to the LLM again, but this time with the evaluation prompts. The evaluation prompt instructs the LLM to grade or apply specific criteria to the outcome, pretty much like how you would ask maybe a human labeler to grade a response. You can look at conciseness, politeness, any of these custom criteria that you come up with. And normally you would ask to provide either a binary outcome or maybe grades in a few classes. So essentially, this is like scaling labeling that you can do using the LLM capabilities that it learned historically. We're going to see an example where we'll apply this method in the demo. So I'm not going to go into detail, but here is a possible ground truth-based evaluation scenario. So for example, you have a question to some ideal expected use case within your application, and you wrote a target response. Then you run it through your LLM, and you collect the responses that you get from your system. And then you can ask another LLM, in this case, the LLM-as-a-judge, to look at both responses and check the correctness between them. And you can instruct what specifically they should look at. So for example, you can ask to look for only contradictions or maybe something else like style match. So in this case, it's actually very flexible. So we're not talking here about like strictly counting words or even like defining semantic similarity. You can give very precise instructions on how to compare. And this method is very powerful, with a little caveat that you actually need to tune your own LLM judge. It's like a small machine learning project in itself. So where you want to get in the end is at a stage where you have a bunch of test data sets that fit your application and evaluators that are tuned to your criteria. And if you do this right, you will be able to answer questions like, for example, hey, if tomorrow there is a new model that is 20 times cheaper than the one I'm using, is it going to be better for my application or not? And if you cannot answer this question today, I encourage you to think how you can answer it tomorrow and maybe invest in evaluations. And the process of building your evaluations is probably going to span around the whole life cycle of your application. So as you've noticed, you're starting with offline evaluations before you just build your system. You run experiments, you evaluate the results, you iterate as you compare prompts to models. And then after you deploy the system, you can put it into production and continue learning from the data sets that you're getting. And in this case, after you collect specific edge cases or errors in production, you can continue learning from these results. Very briefly, a few tips and learnings based on what I said. You've noticed that I talked a lot about issues that can happen, and the first thing that I encourage you to do is to think through risks that might apply to your application, because the real world can bring a lot of real issues. Evaluations take some time, but someone has to do this, and in this case, I would also encourage you to think through who is owning this inside your company. It can be a product manager, it can be an engineer, but someone has to. You still need the data. Even if you're not training your models, you need data for evaluations and designing these test data sets. And last but not least, if you do this right, evaluations are a mode. What I mean by that is that everyone has access to the same models, everyone has access to writing prompts, but you can have access to good labeled data that can help you distinguish between good and bad for your application and evaluators that are tuned to your use case. And that is a very powerful tool. So I'm going to stop here because we have an exciting demo coming up that will show some of these things in practice.
Thank you so much, Elena. That was amazing. We will just take a quick moment to jump into the first poll. And we'd love to hear from all of you. So I'm going to go ahead and launch the first poll question. What methods do you use to evaluate different LLM models for your needs? I would love for everyone to just take a moment, read the question, and check the answer that applies to you. Manual testing, external LLM benchmarks, automated evaluations on custom test datasets, or do you deploy several models and select the best with time?
So my name is Jonathan. As you mentioned, I work in Iguazio, which is a part of McKinsey now. And today I want to show you how we use MLRun, which is an MLOps platform, and Evidently together to monitor LLMs. So let's take a look on this diagram. What we see here is an overview of what we'll see in the demo. So let's start with that part. I hope, yeah, I guess that you can see my mouse. So let's say that we're external users of a chatbot. So we interact with the LLM server and get responses. But behind the scenes, we want to evaluate it over time and gather the data. So for that reason, we need to collect the data. And that can be done easily in MLRun. And we'll see the application based on Evidently, which is connected to Evidently Cloud. And we'll use the LLM-as-a-judge method. And our judge will be OpenAI, an OpenAI model. And we'll store the results over time in a relational database and the time series database, time series DB. And we'll see the results, the graphs in MLRun UI and both Evidently UI. And we'll also act as the monitoring user, the one who is responsible for tracking the system's performance. So here we enter the picture, not only as users, but also as maintainers and developers. So just a second. Okay. Without further ado, let's jump into the Python notebook. And let's start with a simple example. So I guess many of you are familiar with the OpenAI client. So we load here the necessary OpenAI environment variables and import OpenAI and just ask a simple question as users: how many toes do dogs have? And OpenAI responds to us. We get 18 toes. Okay, that's fine. Quite straightforward. Let's see how we wrap that into a model server in MLRun. So MLRun has also its own Python client package, and we connect it to a backend service. Then we create a project. We set the credentials for what we saw before, all the streams and the time series DB. So, and we enable model monitoring. So with that, we can see the results that are sent to the model server after some time. And we also set the secrets from OpenAI again. And that's the Python code that defines our server. So we inherit from this class, the MLRun class of V2 model server. We actually wrap the OpenAI client, and that's our main interaction with it. So the predictions go here. We just send them to OpenAI and return the answer. It can be any other model too. It can be whatever you want, from transformers, Hugging Face, or Olama. Here we just use it to simplify the stuff we do. So we use GPT 3.5 Turbo model, and we set the function in the project. We add the model inputs and outputs. We specify them and the model, and then we set tracking, which enables the model monitoring on the function itself, and deploy it. So after that, we have a live deployment of this model, and we can just call it. So let's just call it now. Let's see a quick demo. Either what countries are in North America, NA, I call that. So we get a response pretty quickly. Okay, that's an elaborate answer, but we won't get into those too much. But that response comes from the model server itself. And we can call it with other questions, multiple questions, and we just create the traffic that we expect for this model. So that's what we basically do here. And okay, we have the model live deployed, and now we want to evaluate it. Okay, so for that reason, for that matter, we want to use Evidently. Evidently's capabilities for evaluating LLMs, and we will connect to the cloud solution of Evidently and our organization, the workspace, and we create an Evidently project. And now we have another OpenAI client, which is the QA assistant. So here we can see our data. We talked about the test data before. So this is our question, and that's the reference that we have. It's kind of the ground truth for those of you who are familiar with this term. And we can see it here in a table format. And after that, we actually have the assistant answer. So we call OpenAI with the model that we saw before, 3.5 Turbo, and that's our output. We want to compare it to target answer. And we can do it fairly easily with Evidently. We just define this data set, and we use the correctness LLM-eval descriptor, and we can generate the report, add it to the workspace, and we can see it also here in the notebook. So we got 2 incorrect answers for a data set, test data set, and 3 correct ones. We'll see later on a bit more details about that in the UI, but that's very nice. We used Evidently as a standalone. Now let's connect it to the model server that we saw before. So just to connect everyone, second, I'm trying to move this. Yeah, so now we're in this part. We are writing the model monitoring Evidently application, which connects MLRun and Evidently to the model server. And then we'll be able to see the results in the UI and in Evidently Cloud. So our application is based on this class, which enables fast integration between MLRun and Evidently. And I won't go over all the details here because it's a bit long, but the main ones is that we see here the QA assistant in that case will provide our reference answer. So our model has its input, output, and this will be our reference. So we'll use a stronger model for the reference. We use GPT-4o mini, and we'll compare our outputs to the output of this GPT-4o mini. And basically, we have the same flow that we saw from before. We create an evaluation data set, run the report on our data set, and we log the results that we saw before in MLRun as an artifact, and also upload it to the workspace. After that, we define the metric and the result that we track. So we track here the share of the correct answers out of all the answers in a specific window, monitored window. And we also track the missing value count as a metric. And after we do that, we can just evaluate our application on the data that we have. So we can just import it and run evaluate with the data from the model itself and get the results. So we can see here the results. We'll also see it in the UI shortly. But after we're confident that our evaluator is doing what it should, does what it should do, so we can just deploy it as a model monitoring application, and it will create the metrics and the results over time, and will automate that for us. So let's see how it looks in the UI now. Yeah, for now. So now we're going to see the UIs, these UIs. And let's start with MLRun. So we have the project, our MLRun project, and we have our model, which we deployed. We call it a model endpoint. And we can see the first mass prediction and the drift status. So we go to the metrics, we can see the inference predictions over time. We can also see the correctness and missing value share metric that we saw from before. So we can see here that we do detect some drift sometimes and sometimes not. So it really depends on possibly on the inputs. So the performance of the model is not I would say, constant with regards to our monitoring application. It doesn't necessarily induce any problem in the model itself, but maybe in the application that we wrote. So for that reason, we need to check it beforehand, the application. And we can see here also the artifacts that I mentioned before, and we saw in the UI, in the Jupyter, sorry. And here we can see that in our last run of this application, we have only incorrect. So it's one incorrect answer from the model. And to get some more details, we can see also the Evidently UI, Evidently Cloud. So you have the Evidently projects, and we can see the dashboard here. And going to some report, and we'll choose that report, this one. And that's a data set, but from each data set we can get to the report. So we can see here we have 6 incorrect and 6 correct. And let's see specific data sets. So how much is 5 plus 1? 6. That's a correct answer. Okay, looks fine. That's kind of the vibe testing that we do. And here we got an incorrect output. Let's see what happened. As of 2020, how many people are in the USA? There are in the USA. As of 2021, 331 million. So now we have an updated answer for that question, and we evaluate it as an incorrect answer. This answer, the original answer of our model, compared to the reference answer. So to summarize, we saw how we can run a model inside MLRun and track it. And we wrote an evidently based application that sends its outputs to MLRun and Evidently. And we can see the results over time in MLRun and dive into more details in Evidently. Obviously, that's just an example, and you can tune it and adapt it to your needs, and you have the freedom to do so. And I think if we do not have any specific questions in that, so I'm passing it back to you, Edith.
Thank you so much. That was incredible to see the code examples and also the different UI dashboards. So thank you so much, Jonathan, for sharing that. We are going to dive into the second poll. Great. So how do you track the performance of a deployed LLM? I track the service availability, but not the LLM output. I have automated flows that monitor LLM performance. I perform manual analysis on historical data, or you don't track deployed LLMs. So do take Elena and Jonathan, you can go ahead and put on your camera. All right, we got a bunch of questions here. So I'm going to ask that question that was asked first. It was in relation to Elena, your presentation. Someone asked if this can be used for RAG application in general when talking about Evidently AI. I think that's the context behind this one. If you don't mind expanding on that, that would be great.
I suspect it's also about using LLM judges for evaluations. And I think that's a spot-on question because RAG is the #1 application we see now in production. And yes, you can use LLM judges and these type of evaluators. So what Jonathan shared was using correctness, where you compare the final response against ground truth, and you can do that. But you can also compare the responses that you get against the context that is being retrieved. And this is what is usually being done to evaluate groundedness of faithfulness in production when you don't have a reference answer. and that's definitely a recommended approach. And relevance, content completeness, and so on, you can design many custom metrics using this approach, which can be tuned to your particular use case and failure modes you observe.
Fantastic. And I know that you both discussed LLM-as-a-judge, so it would be really interesting to answer the next question of, should we use a different LLM compared to base LLM used in apps for use case, or for LLM-as-a-judge?
I can go first, but Jonathan would love to hear your thoughts on that, because I think that's a controversial topic a little bit. My recommendation here would be to choose your LLM evaluation judge model based on criteria that you're using. So sometimes the criteria are very simple. So for example, if you want to evaluate sentiment, you can choose any model. You can choose the cheapest model you have, because probably sentiment detection is a very easy task. If you are looking for contradictions against context and you need like large context, you should choose like a better capable LLM. And it can be the same LLM that you use in the products. It can be better, it can be worse. It really depends on how difficult the evaluation task is. Sometimes it makes sense to use a more capable model for evaluation, and then this way tune your smaller model that you use in production. Sometimes it's vice versa. Johnson, what are your thoughts?
I definitely agree with you, Elena. So what I see nowadays is that people usually use stronger model for evaluation, just as a rule of thumb. But as Elena said, it really depends on the use case.
Fantastic. Thank you both so much. Another question here of, what metrics do we use to evaluate a model?
I think if I'm reading the full question, it was about how are the LLM judges trained, right? So we are talking about evaluating the LLM judges here. And I want to highlight that it's also a brilliant point, because yes, you need to evaluate your judge. It's basically a small machine learning project in itself. So the first step, if you want to create and tune an LLM judge, is to have some manual labels. So for example, I can go myself and manually label things like correct or incorrect, or good or bad, or vice versa. And then when you create a judge, typically it's a classification model. So you pretty much assign a label. Sometimes it's just a binary classification. You can actually evaluate the correctness of these labels against human labels using metrics like precision or recall, or sometimes you can use correlation metrics like Cohen's kappa. So in this case, you can actually tune your judge, and this way you can trust it because you actually evaluate it against your own labels. So this would be my approach. If you can invest some time into tuning this, you should do this. The other way is just to go with first judge the best you can, and then collect this ground truth data set as you go by pretty much interrupting it and making your own corrections based on what you see.
That makes sense. I think this is probably related, Jonathan, to you, but always happy to hear from you as well, Elena. What percentage of time is involved in creating your own questions and answers in order to evaluate an LLM model in production?
So percentage of time, I'm not sure what is the whole that we're discussing here, but if it's about developing, let's say, an LLM solution, so you definitely should invest in it. So even if you want it or not, you will test it. So it's better to have that kind of organized as a test case, as Elena just mentioned in her talk. And so I would say that you need some robust data set of basic answers that you want to get right. And by the way, there are also open data sets that you may use. So I'm not sure about the percentage. I do not have a number, but it's something that you should look into.
Yeah, I think the percentage of time is it's more, I think, more the question of how much should you invest and creating those questions and answers in order. And from what I understood from your question, it's a bit of an investment, but it's worthwhile to do.
If I can maybe chime in a little bit, I would say that it should be really aligned to the risks that are specific to your application. I think sometimes it's safe to deploy your system like as fast as you can, because you can get real data and then use it for testing. But in many cases, like financial use cases, healthcare, you don't have this luxury of experimenting in production, so you should actually invest a lot. And sometimes it can be almost like a labeling project, so it can be quite a worthwhile investment, and sometimes it's inevitable.
Yeah, that makes sense. I guess it very much depends on your use case, the industry that you're in, and the access you have to different data to play with. That makes a lot of sense. So there's a long question here that's very specific to a person's use case. But I want to zoom out a little bit and kind of hear from you guys about effectively detecting drift in LLMs, and what's the recommended size and structure for a test. So it's a long question, and we'll be able to answer more specifically afterwards. But if you can expand a little bit about detecting drift in LLMs.
I think I can maybe start from the standpoint of someone who developed a data drift detection library with my team. I would say with LLMs, actually, we probably don't have this standard definition of drift as we had in classic machine learning, because in machine learning, we usually have like a very constrained problem, right? So we can expect that we're going to apply it specifically on the data that resembles our training set. So this is the assumption that we went in. With LLMs, for example, you might have different users. Like, I don't know, today you have users from one country, tomorrow from another. They come with different questions and so on. So maybe there is like no they can be like technically drift. The topics are different, the behaviors are different, right? But your LM can still do well. So it probably shift the attention from focusing on identifying quality metrics that you can measure, such as hallucinations, correctness, user success rate, user satisfaction, any kind of like quality metrics that are specific to application, and then measure them. And then if you notice change in these metrics, so it's a bit more like classic product analytics in the sense, you can assume that there is some drift. Maybe there are some questions asked on a new topic that you're not handling well. But we are not here applying these methods of like data distribution comparison typically on the use cases that I've seen, because they're usually much smaller, and at the same time they're more diverse from day one. So you expect variety. Jonathan, what are your thoughts here? Yeah, I know that you also played around with data drift.
Yeah, so generally I agree with you, Elena. So it's not as easy. Just we do not have a statistic for that. I did see some people talk about, for example, if we want to compare I mean, comparison of vectors, so of the embeddings, but it's not something that is usually useful. So yeah, I agree. Don't have much to add apart from that.
Sounds good. So you both have a wealth of experience and knowledge. And Elena, I know that, you know, from building Evidently and being the CEO and co-founder, I would love to kind of hear from you if you can share any examples, high level, where where there was a lack of proper LLM evaluation and how it caused major issues within an organization and how it could have been prevented.
You know, I think personally I haven't seen so far like disasters. That's mostly what I've seen happening like elsewhere. And honestly, I have huge respect for the companies who are like courageous enough to test these technologies, because someone has to be like these test cases that we're sharing, right? It means that they're experimenting, right? So I wouldn't like, you know, be very negative about that. But examples that I've seen is that people don't think at all about things can go wrong, because LLMs, they look so capable, they look so smart. So many people actually put external facing chatbots without any testing. And I can promise you, like many chatbots that I've seen, you can just go and ask them to, I don't know, write code in Python, talk about competition, tell me what I should cook for dinner tonight. And they will answer, right? So some of these are benign examples of hijacking, but this also opens up the possibility of misusing your application. So I think this is thing that I've saw most, that people just don't test for it, mostly because they assume that they are too capable from day one. They should be smart enough to not answer this type of questions. But you have to design around that.
Yeah, that makes sense. Okay, so I'm just looking through to see. There was one more question related to when do you suggest to use agents? So I know that agentic AI and agents is another huge topic. So maybe we'd like to hear from you of when you suggest to use agents.
I would say when you cannot go without them. So agent, like any automation, non-deterministic automation is probably the last step that you can try. And if you talk about full-blown agents that actually do the planning, I would postpone it to the very last moment. I would try to design more deterministic flow, sprinkling LLMs or ML in between. So that would be like my conservative standpoint. On the other side, I would say experiment with them everywhere because there are so many powerful use cases that we cannot taught. So just do proper testing and then see what sticks, what does not.
There has been some really great content that we heard today. But before we close, I just want to wrap up by inviting you all to explore our website at iguazio.com, where you'll see here past webinar sessions. This is our 38th session, so there are a lot of other sessions for you to browse, blogs, videos, demos, and a wealth of different resources that may be interesting to you. As always, we'd love to hear your feedback, so feel free to reach out with any additional information you'd like to read about, and I will share those links with you. And thank you all of you for joining the session. It was really a fantastic presentation and a fantastic session today. So thank you all very much, and we look forward to seeing you at our next session.